In this problem, we're given a composite function f of g of x. So before we begin to solve this problem, let's first make sure that we understand what's a composite function. In simple words, a composite function results when two or more functions are combined. Well, that sure doesn't tell us much, does it? Let's understand it with the help of an example. And for that, we might as well consider the composite function f of g of x given to us in this problem as an example. This composite function, f of g of x, it is formed by combining two functions. Which two functions? F of x and g of x in a very specific way to create the composite function f of g of x. So what happens is that the output of the function g of x, it becomes the input of the function f of x. That is, this x in the function f of x, it assumes the value of g of x. And just as a side note, f in the composite function f of g of x is called as the outer function. So if f is called as the outer function, what do you think g is called as? You got it right. G is called as the inner function. So once again, what is a composite function? Speaking in very simple terms, a composite function is a function of a function. All right, now that we know what's a composite function, let's move on to what's given to us in this problem. In this problem, we're given explicit expression for the composite function f of g of x, and we're also given explicit expression for the inner function g of x. And we're asked to find the explicit expression for f of x. So we want to find f of x. What is f of x? F of x is the function where when we substitute this x equal to g of x. So that means, here we go. We get our composite function f of g of x by substituting this x in f of x equal to g of x. What do we get on the right hand side? We get square of x plus 2 minus 5. X plus 2 squared minus 5. And we know that g of x is equal to 2x minus 1. What are we looking for? We're looking for f of x. We're looking for explicit form of the outer function f of x. Now, there is more than one method that we can use to find the expression for f of x. And these two methods, they are not too different from each other, but they are not exactly identical either. We're going to go over both of them. Let's look at method number 1. In method number 1, we're going to call this inner function g of x equal to a new variable. Let's call that new variable as u. So what we're saying is that the inner function g of x, it is equal to a new variable that we're calling as u. Now we know that g of x, it is equal to 2x minus 1. What does it mean? It means that u is equal to 2x minus 1. Next, what we're going to do is we're going to grab this u and we're going to plug it here in place of g of x. So what does this become? In place of f of g of x, we get simply f of u. So watch this. So here we go. We have f of g of x, where we're going to call this g of x as equal to u. Now we know that the explicit expression for f of g of x is equal to square of x plus 2 minus 5. So let's go ahead and write it down. We have square of x plus 2 minus 5. Now, if you look at it, we're saying that f of u is equal to x plus 2 squared minus 5. It kind of looks funny. I mean, f is a function of u. So on the right-hand side, this expression, it should be in terms of u, not in terms of x. So what we're going to do is we're going to express this x here in this equation over here in terms of u. How do we do that? This is what we do. We have u is equal to 2x minus 1. Let's go ahead and add 1 to both sides of this equation. What does that give us? That gives us u plus 1 equal to 2x. Now, go ahead and divide both sides by 2. So these 2's cancel out. We're left with this x, which is equal to u plus 1 divided by 2. Now we're going to substitute this x over here in the expression for f of u as u plus 1 divided by 2. Let's go ahead and do that and see what we get. We get f of u to be equal to, so we're saying that this x over here, we're going to plug that equal to u plus 1 divided by 2. Then we have this plus 2 which is being squared minus 5 over here. All right, from here on, it is simple arithmetic. Let's quickly do that. What do we get inside the parentheses? We get u over 2 plus 1/2. Plus we have 2, it is squared. So all I have done is that u plus 1 divided by 2, I have written it as u½ plus 1/2. And then we have this plus 2 over here, and this whole expression, it is being squared. Then we have minus 5. Let's write this down, minus 5. Okay, what do we get? We get inside the parentheses, u½ plus, we have 1/2 plus 2, which is 5/2. u½ plus 5/2 is squared minus 5. Now, there's this formula, a plus b, square the whole thing. So this is basically a plus b times a plus b. You could multiply it out, and at the end, you're going to end up with a squared plus b squared plus 2ab. Now this formula is going to come handy in a lot of situations. So my suggestion to you is memorize it. Well, after you have used it so many times, you will automatically remember it, like I do. I mean, I have been using it for, I don't know how many years now. Decades probably. All right, now what do we get? All right, so carrying it on, we get inside the parentheses, we get u over 2, square it, plus 5 over 2, square it, plus 2 times u½ times 5/2. So these three terms, they are coming from over here, square of u½ plus 5/2. Plus, then we have this minus 5. All right, this gives us u squared over 4 plus 25 over 4 plus These 2's cancel out. We have 5 over 2u minus 5. Now we're going to combine like terms, and when we do so, this 25 over 4 is going to combine with this minus 5. And it will make it easier if I divide this minus 5 by 4. What do I get now? I get u squared over 4 plus. Let's write this 5 over 2u. Next, what we're going to do is we're going to combine 25 over 4 with minus 20 over 4. We get u squared over 4 plus 5 halves over 5 halves u plus 25 fourths minus 20 over 4 gives us 5 over 4. So this is equal to f as a function of the variable u. Now this variable u over here, in place of this u, we could have had p, t, m, a square, a smiley face, a heart shape, or even a poop emoji if you want. So, does it mean that in place of u, we could have had x? Sure could. And ta-da! As soon as we do that, in place of u, we put an x. What do we get? F of x equals x squared over 4 plus 5 halves times x plus 5 over fourths. And this is exactly what we were asked to solve for. And we got our answer. But like I said, we are going to solve it using 2 different methods. These 2 different methods are, well, they're different, but not drastically different from each other. So let's see how we're going to solve the same problem using method number 2. In method number 2, we're going to make use of the fact that if for the inner function g of x, there exists its inverse. Not all functions will have inverse functions, but let's say if for the inner function g of x, there exists an inverse function, g inverse of x, such that g inverse of x. That means instead of this x, we are plugging in this inverse function of g. Then this equals x. And if I take this g inverse of x, and for this x, I put in the inner function g of x, I will again end up with x. Let me write it down. G inverse of g of x. This is also equal to x. In that case, what we're going to do is we're going to solve for this g inverse of x. How? Because we are given the explicit form of g of x, which is equal to 2x minus 1. So from here, what we do is we solve for g inverse of x. Then, in the next step, we move on to the composite function, which is f of g of x. What we're going to do is, in place of this x over here, we're going to substitute g inverse of x. What would this do? So what we get is f of g inverse of x. And by definition, g of g inverse of x is equal to x. So what do we end up with? We end up with f of x. And that is exactly what we want to solve for in this problem. So let's go ahead and figure out the inverse function of g of x in case it exists. So to do that, we're going to begin with g of x. And what is that equal to? We're given that g of x is equal to 2x minus 1. Let's call g of x as y, just to make things simple and to write them in a more conventional form. So here, we're saying that when the input is x, the output is y. So for the inverse function, what we want is that when the input is y, we want the output to be x. That's what inverse means. So to do that, we are going to solve this equation for x, which we have already done actually when we wrote g of x equal to u in method number 1. And using the same logic, we get x to be equal to y plus 1 divided by 2. So what we're saying is that, but now the convention is that the input is x and output is y. To match this x equal to y plus 1 divided by 2 with the convention, we're going to swap x and y. And that gives us y equal to x plus 1 divided by 2. And this y here, this is the inverse function of g. So just once again, initially we said we have this g of x. We call that as y. It was equal to 2x minus 1. Here x is the input and y is the output. We want to find inverse function of g of x such that the output will be x when the input is y. To do that, we solve for this x because we want x to be the output now. And input is y, so we're solving x in terms of y. So this here, this is actually our g inverse of x. But just to write it in familiar form, in conventional form, we're going to swap x and y. So y becomes along the y-axis and x becomes along the x-axis. And this new y, this is the inverse function of g of x. And to verify that this is indeed the inverse function, we can do our mathematic and find out. In g of x, which is equal to 2x minus 1, let's write this x equal to g inverse of x. Now, what is the value of g inverse of x? It is equal to x plus 1 divided by 2. So what we're going to do is we're going to write in place of this x over here, we're going to write x plus 1 divided by 2 minus 1. What does this give us? So here these 2's cancel out. We're left with x plus 1 minus 1 equal to x. So there you go. This g inverse of x that we called as equal to x plus 1 divided by 2 is indeed inverse function of x. So now, back to the problem at hand. We have f of g of x. And this is equal to x plus 2 squared minus 5. So what we're going to do is we're going to write this as f of g in place of this x now. We're going to write g inverse of x. That means on the right hand side, this x, it is going to become g inverse of x. That means this x over here is going to be x plus 1 divided by 2. To this, we are going to add 2, then we're going to square it, minus 5. Now watch this. This is the same expression on the right-hand side as we had in method 1. Here, I have u plus 1 over 2 plus 2 all squared minus 5. And here we have the same expression, just in terms of x instead of u. Very quickly, let's solve this expression on the left-hand side, just like we did in the method 1. So here we go. We get x half plus 1 half plus 2 squared minus 5. Inside the parentheses, we get x half. Then we combine 1 half and 2 to give us 5 halves. And this parentheses is squared now, minus 5. Using the same formula that we used before, once again, the formula was a plus b squared equals a squared plus b squared plus 2ab. Here, we're saying a is like x half and b is like 5 halves. And when we use this formula, what do we get? All right, let's fix the color. When we use the formula, we get x over 2 squared plus 5 over 2 squared plus 2 times x over 2 times 5 over 2. And this expression is now the square of x half plus 5 half. Then we have this minus 5. Let's write it down. Okay, let's get rid of this line. What do we get? The first term inside the parentheses gives us x squared over 4. The second term inside the parentheses is 25 over 4. And the third term, that is going to be, let's cancel these 2's first. And now the third term becomes 5 over 2x. And then outside the parentheses, we have minus 5. We're now going to combine like terms and also write these in the order of the powers. The highest power of x is 2, so writing that first gives us x squared over 4. The next power of x is 1, so writing 5 over 2x. Lastly, we're going to combine 25 over 4 with minus 5. And to do that, just like we did before, this last term, minus 5, we're going to multiply divided by 4. All right, so this becomes x squared over 4 plus 5 over 2x plus 25 over 4 minus 20 over 4. Now this 25 over 4 minus 20 over 4, this gives us, here, let's write it down. This will give us 5 over 4. Now this entire expression on the right-hand side becomes x squared over 4 plus 5 over 2x plus 5 over 4. And what do we have on the left-hand side? We have f of x. And here you go. This is exactly what we set out to solve for. Problem solved using two different methods. In method number 2, we found out the inverse of the inner function g of x and used that. And in the first method, we wrote the inner function as equal to a new variable, u, and then we solve for x in terms of u. After doing so, we made the substitution in the original equation in terms of u. And at the end, we substituted u equal to x over here. And here we go. Our problem is solved.